So next Wednesday, we're already looking November. So things are wrapping up. Things are getting really close to the finish line. Once you get to the break, winter break, it goes really fast after that. So, yeah, then it's just a race to the end, basically. So let's start with probabilities. I have my calculator ready. There's going to be some things that I need to make sure you understand. You may not have seen them in grade 11 in terms of rounding and stating your answers, especially when it comes to probability. So I will get into what probability actually is, define it and all that, but first let's talk, and some of this is review because I know you've done probability in your younger years. I know. Probably grade 8, yeah, grade 8, 7, 8, somewhere in there. Maybe even earlier, that's okay. So probability can be stated in 4 ways, right? It can be stated as a fraction, it's a decimal, percentage, and in words, okay? So words is the easiest one. It's just saying 1 out of 3. That's basically how you would state that in words. Let's get that one out of the way. That's the easiest. But you might see like there's 1/3 equals and then decimal, percentage, and words, right? So what you need to make sure you understand is before you state anything as a decimal or percentage, let's find out what this is as a decimal, right? So 1 divided by 3, and it's actually 0.33 repeated. So you want to kind of show as many 3s as possible. And so this is like your calculator screen. I'm going to try to draw my calculator here. Hey. So you've got a bunch of buttons. Okay. There's the equal. There's the on button. It doesn't matter, but that's your calculator right here. And did you know that your calculator has a precision as well? The calculator cannot show all the 3s, right? At some point, the calculator just says, this is all I can do for you. So the precision of this would be what? 0.000000001. That's the precision of my calculator. There's probably calculators out there that have more, but I'm limited. So that's just a review of precision measurement. So if you want to state it as a decimal, you got to round it to 2 decimals. So in this case, it would be 0.33. Right? So you're basically, all the 3s that follow here, right, you cancel them. Then you go back to your calculator. If you wanted to state this as a percentage, we go back to our calculator and we just go times 100. So we multiply our answer on the screen by 100 and you get 33.33%. So what I'm trying to say here is always go back to your calculator, because some students would, if I said, hey, state 1/3 as a decimal and percentage, you know what they would do most likely? They would go 0.33 and then they would just multiply this by 100 and say 33%. Right? And the province would say that's not rounded correctly. They always want you to go back to your calculator before you go branch off into any of these. Okay? So let's try that one more time. You want to try this? 2/7. Put down what it says on your screen. So write down at least 4 decimals or so, and then give me the decimal answer, the percentage, and the words. See if you can do it after just one short example. So just do that, not much. There's your answer, right? So that's what my calculator gave me. And then if I round that to 2 decimals, right, I cut it right here. So the 5 bumps the 8 to a 9. So that'd be the correct answer there. And then percentage, I go back to this times 100, and it actually ends up being 28.57%. Another tidbit here for you. You can, right? You may round to 4 decimals if you want. Right? So you could round this answer. So let me go 2 divided by 7 to 4 decimals. So that would be 0.2857, right? If I take 4 decimals like that, that's okay. And then you can just multiply this by 100 to get that. The province says if you need to give me at least 2 decimals or more. Okay? It's okay to go more, except for money. Money they're really picky with. Money, 2 decimals, no matter what. If it's $52.2, you got to go 52.20. Okay. Ideally, I would want to have no rounding errors on the exam. See if you can meet that challenge. Okay. So then you might encounter something like this, where you go from fraction to decimal to percentage, or any which way. So if you have a decimal, if this is given, I'm going to go here. I just multiply whatever is there by 100. So that'd be 19.2%. If you multiply that by 100, you get 19.2%. And this is, I don't know if this is still being taught in school. I don't know if this skill, going from a decimal to a fraction, would anybody remember how to do that? You don't multiply, this is the trick. Can I want to explain to you why this works. This would be tens, right? Hundreds, thousands. So you have 192 thousands. That's what you have there. Okay. Can you reduce that fraction? Yes, you can, but in this course, I'm not really going to be a stickler on that because the province doesn't require you to reduce a fraction. So let's maybe not worry about that because sometimes that causes a lot of anxiety, reducing a fraction. But you need to know how to do this, right? So should I say this would be tenths, right? This would be your hundredths. I know I'm exaggerating, and these would be your thousands. And then it's 10,000s and so forth, right? But I would just say, look at how many decimal places there are. There are 3, right? So the number down here just has to have the same number of zeros than your number up here. So if you had a 4-digit number, then you would have 4 zeros following the 1, and then that's another way of doing it. Okay. So I know it's like, what? That's news to me. So if you go from percentage to decimal, which I would encourage you to do, you divide by 100. So that one I would expect you to know how to do. Multiply by 100, divide by 100. Because this is really 35.75 out of 100. So 35.75. Morning. Right? So you get that into a decimal. And then we're going to turn this into a fraction. Okay? You got the booklet, right, Colton? On page 2. So we go, watch this. This is so much fun once you know how to do it, right? There are 4 digits, so you go 1 followed by 4 zeros, and that's your fraction. Some of your calculators are all fancy. They will actually reduce the fraction. Yeah, so you could do it that way. That's another reason why I don't really give marks for it, because some of you can just type it in, boom, you get it. And some of you would have to be stuck trying to reduce it. I might still teach you how to do it. There are some quicker ways of doing it, but not right now. Okay, we are fraction, right? We're going to turn that into a decimal. So you just go 185 divided by 237. And there you go. I'm going to do 4 decimals, okay, guys? So what would that be rounded to 4 decimals? 0.7806. So, and then if you multiply that by 100, that's 78.06%. Okay, so you got to make sure, show yourselves how you went about it, right? So it's actually not too bad if you know. And when you're a decimal, it really doesn't matter which way you go if you have a decimal already. So if it's a decimal, we multiply by 100, and that gives you 12.34%. And then from there we went here. So it's 1, 2, 3, 4 over 1 followed by 4 zeros. Okay. So that's your chart there. Most of the time, a test has at least a few of these, just to make sure you know how to do it. And the province gives you a full mark if you know how to do it. These are easier to get, right? If you just know how to do it. We're good? So page 3 is simplifying fractions. And I'm just going to skip that for now, okay? So let's keep going to a deck of cards. I'm not really skipping it. I'm just choosing, right? Like I usually try to reteach it at some point. So we'll see how time goes. Deck of cards. I used to assume students know their deck of cards, and it's not really the case. And I don't blame you, because some of you just don't play cards, right? So in general, when a question talks about a standard deck of cards, it does not include the jokers. So we have 52 cards in total. Right? So maybe highlight that, like a deck of cards has 52 cards. Why is this important? Because a lot of my probability questions will involve a deck of cards. Okay. Then you have 4 suits, right? You have your clubs, your spades, hearts, and diamonds. And each of them have 13, right? I will show you a quick way to put this on your study sheet. Just follow along. So 4 times 13 is 52, right? Half of them are black cards and half of them are red, okay? So you kind of split the deck in half by doing that. And it always goes ace, so that's kind of like your 1, right? Ace, 2 to 10, and then it goes jack, queen, king. And these ones at the end here are called face cards. They show up quite often. Okay, there are 12 face cards, 3 per suit, right? 3 per suit. So the clubs have 3, the spades have 3, hearts have 3, and the diamonds have 3 cards, 3 face cards. So keep that in mind. These ones, I'm gonna add this. These ones in the middle, from 2 all the way to 10, are called numbered cards. How many numbered cards are there? There are a couple ways of doing it. Watch this. 52 minus the 12 face cards. That's 40, right? Minus the 4 aces. That's 36. So 36 cards would be considered numbered. And you could also just say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbered cards for this suit. So let's just go 9 times 4, still gives you 36. Okay, so regardless of how you do it. And then 4 aces, right? 4 aces. So 4 aces, 36 numbered cards, and then 12 face cards. That gives you a total of 52 cards. Okay. Here's my cheat sheet entry that I would suggest, unless you really know your deck of cards. So here it is. I would say a deck of cards, like if you want a little title, you grab your 52 and then you just branch off. There are 26 black cards, 26 red. And the black cards are split into two. So you've got clubs and spades. Then you have your hearts and diamonds. And each of them have 13. And this is only maybe for one that you need to do it. It would be comprised of ace, 2 to 10, jack, queen, king. Okay? But if you need to do it for every single one, I wouldn't blame you. Right? But this is, you need to know your deck of cards. I can't help you on a test anymore, okay, with that. So that's, if you can shrink this down to let me just zoom into it because maybe you're like, what does it say there? So if I ask you what's the probability of drawing a black card, it would be 26 out of 52. Okay? What's the probability of drawing a king? Just any king. How many kings are there? There are 4. 4 out of 52 chances, right? And so how many red jacks can you grab out of a deck of cards? Red jacks. You should be able to be like, oh, there's only 2 red jacks, right? So 2 out of 52. So this kind of just summarizes it neatly. Well, you might disagree, but that's the best I can come up with. If you make something better let me know, and so I can share it with everybody else. So study sheet. Study sheet. I don't often tell you exactly what to put on there, but this would definitely be one of them. Okay, I basically set the stage for probability. I reviewed some terms. I reviewed how to turn decimal to fraction and all that. I showed you how to round properly if you want to state it as a decimal or percent. And now we're going to actually look into what is probability. Okay. We use it all the time. When you look at the forecast, there's always a chance of snow, a chance of rain, a chance of this and that, right? So there's probability all the time. And sports, right? They often call it odds, the odds of someone winning the championship or the game, right? So let's go to page 5 here. So what's probability? It is basically, probability is the likelihood of an event happening, okay? We usually state it as a fraction, but sometimes we do turn it into a decimal. And this is the fancier way of looking at probability. The probability of events, so you fill in the blank, of dice landing on a certain number, on the coin landing on either heads or tails, you name it. On the spinner landing, Price is Right? Have you ever seen the big spinner there? Right? The probability of something landing somewhere, all of that, it really comes down to, watch this. There's a total possible number of outcomes. And then there's number of favorable outcomes, like the times you would actually get what you want, what you're expecting to get, right? That's really what it comes down to. So total, so favorable over total, okay? A key concept to remember, that the probability of an event happening and the probability of the event not happening is always going to add up to 100%. So if they say 40% chance of rain, that means, right, that means that there's a 60% chance of it not raining. So combined, it adds up to 100%, or 1. Why is it 1? Well, because you can turn 40% to 0.4 or 60% to 0.6, it would add up to 1. It's the same concept, right? And I want you to be familiar with that. Probability of the event happening plus probability of the event not happening. So can we highlight the little bar? It's not a typo. That means not, right? So they say it one more time here. E bar, or E with a little apostrophe there, means against or not. You can say not happening. Okay. Why is that helpful? It is, remember the supplementary angles? Supplementary, if you know one, you know the other. Same idea here, right? That means that if you know one of the probabilities, you can find the other. So the probability of an event happening would be 1 minus the probability of it not happening. And right now this might be gibberish to you, and that's fine. The probability of something not happening, you just take 1 or 100% and take away the probability of something happening, and you get your answer that way. It comes in handy sometime. Okay, next. A fair game has a probability of winning 50%, right? That would be a fair game. So let's highlight that. A fair game would be saying if you can win 50% of the time. So none of the Red River X games, right? None of them are fair. You always lose money. A 0% chance means that, right, is impossible, while 100% chance means it's just certain that you're going to win. Okay, so if you ever come across those, 0 impossible to win, 100 obviously it's certain that you're going to win. Let's do an example here. There are 20 students in Mr. Dirkson's class. Actually, today is a lot less than that, right? He knows that 7 of those students drive a car to school. Okay. A, state the probability of a random student driving to school. And I want you to state it in these 3 formats. Okay, so let's do that here. Let's write it officially the way, with the proper notation for today. So probability of a student driving would be, how many drive? 7 drive out of 20 total. There are 20 students in that class. Okay. So the probability is 7 out of 20. So we'll just say that that's 7 out of 20, comma, let's turn it into a decimal. 7 divided by 20. Oh, it's exactly 0.35. Which, if you multiply that by 100, it's just 35%, because we don't need to worry about more decimals, because it actually ends. It's a finite number. So there you go. So randomly, if you picked a random student, and there's a 35% chance that that student will be driving, right? So it's random is always implied. If you have a bag of candies and there's certain chocolates in there, like different colors, the wrapping, if you look, this is out the window. Like whatever we're calculating here is out the window, because now you're skewing it. You're like, oh, I want the green one, right? Like my voice always like pick the one, right? But if you were to randomly draw one, or if you come into the classroom and just pick a random student, In this case, there's a 35% chance that that student will be driving. Okay, that's what we're trying to answer here. So we did it in all three ways. B, state the probability of a random student not driving to school. Show two ways of determining this. Here, B, probability. Let's just do it this way. I'm going to do this, watch. I need you to be comfortable with that. I'm saying with that notation, I'm saying, hey, what's the probability of someone not driving? Okay, that would be 20 total. How many students do not drive? This one is pretty easy. 13. I'm going to show it a different way. Would that make sense? 13 out of 20 do not drive. You already know what the answer is as a decimal, I hope, just by looking at your values. But if you don't, 0.65, which is 65%. So what do these two add up to? 100%, which is what we want, right? A student driving, a student not driving adds up to 100%. Watch this. These two add up to 1, right? If you were to add up these two, you get 1. If you add up the percentages, you get 100%. That's exactly what we want. Okay. And it's saying show two ways of determining this, or let's write this down, probability of driving. Just focus on how I do it. I know you know the answer. Let's get that mouse out of the way there. Probability of not driving, what I would do is 1 minus 0.35, let's say. Like I'm going to take away 0.35 from 1, which gives me 0.65, which is 65%. Same thing. Okay. So that's your two ways of answering that same question there. Okay, let's keep going here. Page 6. I think I'm already going to ask you to do this on your own. I have a feeling that you know how to do it. But if I'm wrong, you have an eraser, right? If not, I can borrow you one. So let's go to page 6. Careful with the notation. And if you don't know one, leave it. No, don't leave it blank. You try it. If it's wrong, nothing's going to happen to you, I promise. I want you to find the probability of the spinner landing on red. How would you write that down? Just as a fraction. Just give me that as a fraction. Probability of yellow, probability of blue, probability of not landing on yellow. Ooh, how do I do that one, right? So give this a try, please, and I will go over it in a bit. I just want you to kind of wake up a little bit, okay? And to give it a try. If you don't try, you're probably not going to learn as okay. I just have you to know something. When I make my lessons, I go backwards. So what does that mean? I kind of know what the province wants you to know. Like I know quite well over the years, right? So this booklet is like a year old, maybe. Like I made these brand new. So I go back and I kind of already make questions that make you think a certain way, right? And so when I explain, I use them to prepare you for what is to come, right? So when it comes to probability, notice what it says up here. In this case, the total needs to be determined. Earlier, I just gave you this 20 students in the class. Sometimes you need to determine that yourself. So make sure you write down total is 8 sections, right? There are 8 possible sections this thing can land on. So every single fraction in this case should be out of 8, okay? 8. And then probability of it landing on red, there are 1, 2, 3 red sections. So that's it. I'm going to do the decimal in a bit. Right now I'm just going to do a fraction. Probability of yellow, there's only one yellow section. Okay. Probability of blue, still out of 8. There's 1, 2, I just count 2. That's a quarter, right? 1/4. 2 goes into both of them. So these ones would actually be fairly easy to simplify if you could. Probability of not yellow, watch this. Some of you, I saw you do that. I like you doing it. Probability of not yellow, I take my total and I subtract the yellows, right? There's one yellow section there. So you take away the yellows. So that means that 7 out of 8 are not, that's your chance of it not landing on yellow. Okay. Probability of red, same thing. 8, take your total, subtract the reds, and we did that earlier already. 3, there are 3 of them. So I subtract that, so it's 5/8. Okay, I will say this is yellow. For your notes later, right? So that is red. And so I take away those so that I'm left with not, right? Green or yellow? What does or mean? It means plus. It means like it could be either or, it doesn't matter. You're going to win the prize if it lands on either one of them. So we go 8, and then you grab your greens. There are 2 of them, and there's 1 yellow. Okay, so this would still be, the chances of this event happening would be 3 out of 8. Okay, probability of blue or red, it's still out of 8. So you grab your blue. I have 2 blues, and I have 3 reds. So that's 5 out of 8. Okay. And now I'm going to give you the decimals real quick here. So just write that down. I'm going to go fraction decimal. So I have that already done. So if you just want to copy this or make sure you get this right. 2 divided by 8, that's a quarter. Some of you realize that later on. 7 out of 8 would be 0.875 or 87.5%. 5/8, it's 0.625 or 62.5. 3 out of 8, I can just copy the very first one. And then 5 out of 8, I'm just going to copy the previous one up here. So those are your decimal and percentages there. So remember, it's always, you need to figure out your total and you need to figure out what the numerator has for you. Okay. It's going to get trickier. So I'm going to do deck of cards. I'm going to do a bunch of different things here. So stay with me. Okay. Last one, last concept, and then I'm going to ask you to do some work for the rest of today's class. Can you handle that? Yeah. Making predictions, highlight that. This is going to happen a lot. I'm going to ask you, like, hey, can you predict what's going to happen on a larger scale? Okay. When we state probability, we can use it to make a prediction, right? We can use the probability to make a prediction. We essentially are, you remember that word extrapolating? Have you ever heard of that? Extra, think of extra. You're going above and beyond what you're currently seeing. You're going in the forecasting mode, right? And so this is, I would highlight this. Prediction is really probability of an event, probability of the event times the greater sample size. That's what that is. That's how you do that. And a sample size is, right, what is the amount of people or the amount of surveys you've done or whatever, right? The amount of rolls you've performed, the amount of times you spun the spinner, all of those things that's a sample size when you collect it. If you were to spin the spinner above 350 times, right? how many times would it land on yellow? So we go prediction. Make sure you write this down, okay? Prediction is probability of yellow times larger sample. Okay. So what's the probability of it landing on yellow if you go way up there? It's B, right? 1/8. You take that, and then you multiply by 350 spins. Okay. So you're predicting what's going to happen on a larger scale, 350 spins. So you grab your calculator. Watch how I'm going to do it. I'm going to go 1 divided by 8 equals times 350. You get 43.75. Okay, 43.75, but that's approximately 43 or 44 times. Okay, make sure you round to a whole number there. So you're saying based on my probability, if I spun this thing 350 times, right? I just multiply it by the probability of it landing on yellow times, this could be 2,000 times, it doesn't matter. The steps would be the same. So this is how many times you predict it's going to happen. This is called theoretical probability. In theory, if the spinner is not skewed, if there's no magnet in the back, right? Yeah, go ahead.
I use fraction mode, that do I still have to round that to?
Yeah, so I want you to write down whatever you get, but then you round to a whole number. Okay, because round to whole number. Yes, so these events you're going to have to round either up or down. It doesn't matter. Okay. Watch this. If the wheel was spun 199 times, how many times would it land on red? I'm going to just cut right down to the work here. Probability of red, I'm going to look up there, is 3 out of 8. And I'm going to multiply it by 199 spins. We're going to do the same thing with, like, let's say, you know, out of 1,000 people surveyed, 150 said they would vote for a certain candidate. So now, if that city has 25,000 people, how many are you expecting to vote for that candidate based on your survey? That's how you go forward. So you can go 3 times 199 if you want, divided by 8. That's fine as well. It doesn't matter if you do this first, then multiply, or multiply these two and then divide. You get 74.625, which is approximately 74 or 75 times. Okay, that would be a correct final answer. Okay, now come with me. I want to tell you what's in store for you. I'm gonna have some chocolate questions. I like my chocolate. My wife likes chocolate. So we have chocolate questions. Think of this as the spinner. There's just no spinner, right? There's just chocolates. And then go to page 8, where I ask you to state the probability based on a standard deck of cards. There's no way around this, guys. You watch me do it, you might be like, I kind of get it. You can listen to the YouTube video again, you can watch it again, yeah, I kind of get it. But you have to actually do it to become better at it. So I'm going to ask you to do 7, 8, and I'm just going to ask you to stop at 10 to do this chart here. You don't have to simplify fractions if you don't want to. So I'm going to say 7 to 10 for the rest of today. Okay, and I will post the key shortly. So homework or schoolwork, that would be much better if you do it right here today before you go home. And even if you start it here, research shows that if you start something in school, you're more likely to actually pick it up again at home. Okay. So that's what I'm doing that. Smash the like button, hit the notification bell,